Okay. So yeah, so this example about testing the reachability of the robotic arm, you can actually make any CAD model separately on SolidWorks, but you have to save it in different format and bring a robotic arm. You can even make this handle, or you can online with the video I send you. But at the end of the video, actually, you can find the suction port, and or you can use the welding tool available with the Robot Studio. Put it on the robotic arm and start to touch some points, simulating the, for example, the welding operation, or a spot welding operation is going to be by point, or just do the picking and dropping of the parts in different places. You can see they can do something similar to that, but the object is going to be different. It doesn't have to be the same one exactly. Okay. When you learn how to move the parts in the first time, the other step is going to be quite simple. And actually, the video I sent you show you how to do that step by step. So it doesn't have to be something complicated. Okay, so this can be a good example. I think there's this tutorial I'm talking about for the grubber and the making the target. Tool number 2, I think from the same people. No, this is from Giant. Okay, now we don't have, I don't think we have this grubber. Anyway, this can be a good example as well. You can have the same robotic arm, the same grubber, which is available in the library, but make your own CAD model as a part of the novelty. Import the CAD models to the robotic studio and just pick and place the parts. This can be another example. Or just have a box, or this can be a cylindrical shape, and try to put as the end effector one of the welding devices which is available in the library, and try to simulate that you do the welding around this spot. Okay. Now the main thing is just show me that you learned how to use your Robot Studio. More complexity, of course, is going to be the best mark, but we don't expect that everyone is going to have a full mark in this assignment, right? So have you thought about IDs now?
How complex do you expect us to, if you go for a full mark?
I said nobody going to get full mark.
I'm just saying, yeah. How complex would you be expecting us to go?
Okay, now I'll tell you what one of the students did last semester. He almost got a full mark. Okay. I'm not sure if we're going to find the video, but what he's done is that he got one of this Lego toy. Okay, the Lego toys, this spaceman, and he brought the parts to the robotic studio, and he started to pick the parts and assemble it together.
Okay.
Then he brought the welding end effector and start to weld the parts. Okay. So he brought the 3 robotic arms. He put one of them, 2 of them had the grabber, and one of them had the welding machine.
Oh, so the arm puts the Lego together and then welds it.
Yeah, that's what he done.
Yeah.
Okay, that was a brilliant idea, I think, at that time. I think the one of the student also, he had something similar to this one. Like you can see, this one is 2-hour tutorial, and he had conveyor belts too, and he was just picking and he placed the part between these conveyor belts, something like picking and placing. Okay, I will share this one as well. You can see this one is 2-hour thing. I don't actually want you to be to that depth, but this you need to learn this one. Actually, you can add this one to your resume, put a link on YouTube, and put within your resume to be an example of your application for the Robot Studio. This is actually going to be a bright thing in your resume if you're going to do it.
Yeah, that's what I'm saying, because
Yeah.
A lot of the content this semester's got me my internship, so I wanted to kind of make this count.
That's great. Yeah.
Yeah.
And actually, I'm thinking about something else which can help you as well. Like, for example, maybe, let's wait for this noise. Okay. So I think that many of you didn't learn how to use the answers for the CFD.
No, we didn't.
Have you done? I think the master student did. Have you done answers? Yeah, is it software called answers?
I haven't. I've done not CFD, but I've done like an intro course for the FEA stuff.
Okay.
Yeah.
We use SolidWorks for CFD in fluids.
Yeah, I know that. Yeah, and fluid dynamics. Who teach you that? Is it Peter or Fook?
Fook.
Fook, yeah. Yep. What I like with the SolidWorks, the flow sim, they used to call it flow sim or sim flow, whatever the name is, that the meshing is very
flow simulation.
easy. Yeah. No, I mean the old name. Yeah, the meshing is very easy because make it from 1 to 7. You can choose anything from 1 to 7. And in all the cases, you're not going to have any problems. The more complicated thing is what we do with the answers. The good thing with the answers, it's able not to do the fluid to fluid heat exchanging, but also can do it with phase change. You can take it from vapor to liquid, from liquid to vapor. Anyway, I can put you at the beginning of this one. You still have the access to the VMware, and you can learn how to use it. I can give you some short example. Even for the SolidWorks, I can show you, for example, how to do the duct design using the SolidWorks flow sim. And this will be out of any subject. Oh, by the way, for those who hadn't done the air conditioning, the school says that they're not going to run the air conditioning in autumn 2021 because they would like to reduce the number of the subjects down to 17 because they don't have the budget to run all the subjects. I suggest that we may able to run the subject during the summer, but it's going to be a 4 credit point subject short course. They call it short course, but in all the cases, I can train you to write down, for example, the energy tuning report for a building, which is something actually again to do in the real life if you're going to work in the HVAC industry. So we can end up with calculating the building heating and cooling loads. We can end up with doing the building modification for the energy envelope, and we can do the simulation for the energy consumptions and how we can reduce that, and end up with doing the calculation for the environmental impact, how much CO2, for example, are going to save if we save a certain amount of energy. However, go back to the project. Now you can see that's what we've done here. All these conveyor belts are built in within the software. And even this box, you don't have to build it outside. You can make it within the software, unless we're going to be a quite complicated shape. And then he's going to run it on this conveyor belt to a certain point, pick it, and put it on the other conveyor belt. This is long tutorial because I think he's going to go to the details step by step. That's why I shared this one with you. Oh, you have 2 robotics arms now. Okay, I think this will be great work after all. Is he adding the welding operation? Yeah, I think he adding welding operation as well. It's not only pick and place. So this can be a good example. This one is just doing between. You cannot hear the voice, of course, but yeah, I think this short one, once again, is going to do the conveyor tracking system. So that's one of the student already done, and I think he already submit this assignment. He had a conveyor built, he had the CNC turning machine, And he picked the part, put it inside the machine, close the door, start the machining. That's something we cannot see. Then when at the end of the operation, he picked the part and put it back on the conveyor belt. That's a good example. And I think that I was trying to show you something. I think this is an example within the, oh no, yeah, he making a cell. He doing a flexible manufacturing cell. He's doing. But I think that these short videos, not again to show you the programming, the step-by-step programming, because they did earlier. You cannot see many details in an 11 or 15 minutes. Oh no, I think it does. Yeah. So the main thing is you're going to put the points, and you're going to ask the machine to move these between these points either one after the other, or maybe you can pass the odd and the even thing and come back to them later. We call them a target, and he's going to show you here how he's going to start to move to this one. Okay, I'm going to share this one with you. One of the other idea we have is doing what was it? Let's go to my channel actually. And I will show you the major project that we used to do in the lab while using the ABB robotics. And now we're doing it with major project. Yeah. So we used to do it in the lab, but still we can do the same thing by using the robotics. Now, take a look to what we've done here. We have these parts, and we have different solution for the T-Basel. So you can make these parts by the as a CAD parts and import it to your machine, to your program, and then start to simply fix them in one of the T-Basel. Here they're going to do it in two solution. You can simply just make it as one, because this one is going to require flipping for the parts. You're going to make one parts, you don't have to do it, or one solution, you don't have to do any flipping. So I'm going to share the documents for the major project from previous years. And you are going to have the dimensions for the parts. So just make them as a CAD model, import it to your device, and use the different solutions among the T-Basel solutions and make it just one. You don't have to make any. We can consider this one as an assembly process. That's what I considered in the old days. And actually the task was to ask the student to use the shortest time to do the assembly and de-assembly process. Because you can see this one, they de-assemble the part, again to put it on the other solution, the T-Basel. Each group had two solutions. Now for your case, once again, the grabber, this grabber, can be found on YouTube. For the first video I sent, again to try to download the grabber and share it with you. And well, you can see that they use a higher programming capability to do the flipping of the part on the holder. So I'm missing these days, but the students were enjoying the thing. And I'm picking the last one. Just give you 1 second to find the assignment paper, and we can have a discussion about that. By the way, I would like you to talk to each other because you will exchange experience. And also what we are going to have, if you are going to do this assignment solutions as the the major assignment from the previous year, doing this solution, if you are going to decide to do this one, you can share the parts, the CAD models, and also you can avoid having the same, we don't need this one. We are going to avoid having the same part to be shared by all the students. So what is that? Assignment number 6, major project, and 2000. Just does it cover sheet? Okay, so that was the point. You only have to put the parts here, and making for you are going to make one of the solutions. These are the dimensions if you would like to make the CAD model for it, and you need to choose one of these solutions. Okay, so you have to fix the parts in a way that they're not going to be, no need to be flipped, because I know the operation of flipping is going to be quite complicated if you are going to try to do it on the Robot Studio for a reason or another, because I need to teach you that myself. So you can choose any one of these solutions. We had 27. Once again, you can talk to each other. So for example, if Brian going to take number 7, no one else is going to use it, just him. Okay, and to make the work is quite complicated, you can make a tutorial about that. You can describe what you're doing, and actually this will give your work some novelty, and you can you're going to be unique among the others. Is that clear? No, I will do it.
Yeah. Yep.
Okay. So for the downloading all the software, once again, we're going to go to here. I think that Peter got his work by simply following the details we have here.
Yeah, I'm just installing it now, so I'm just checking if
Yep.
it works, because it comes up with that option to use a trial.
Yep.
As soon as you install it. So
Yeah, actually, it's actually to have the trial, but their website mentioning that the trial actually is going to be extended till the end of the year. And
yeah.
actually, that's
yeah, I
happening
think
because,
mine's working.
yeah, that's great.
Yeah.
Okay. Now, of course, you can download. There's a question from the student asking, can we download the CAD models from the from online resource? Yes, you can. If you're using the CAD GrabCAD, yeah, just get it down and try to assemble it as a part of the car. But do you think that the car is going to be quite complicated? Try to minimize the parts. Okay, so that will be for the part A. Now let's talk about the, okay, yeah, the windshield, yeah. Now for the part B, you need to write down an essay. It's going to be a short one. Let me find the document we have, A 2020, and the assignment number 4. Oh, no, I call this assignment number 6 here. Okay, so just give me 1 second. View show modified. Okay. It's much easier to find it on UTS online. Now for the essay, as I told you, you're only going to you're only going to do something to improve a certain process. Now, this can be anything to do any process of design for X. It can be designed for manufacturing. It can be designed for environment. It can be designed for assembly, or designed for manufacturing. So if you go to the assignments here. Okay, assignment number 4. And the document. Just give me 1 second. Okay, so this is the part we're talking about, 60%. And that the other part, designed for manufacturing and assembly. You can use any process of DFX. It doesn't have to be DFMA. So you talk about take any products, anything, okay, and analyze any selected product, manufacturing and assembly process using the product engineering drawings, again, to be permitted. Give some suggestions how to simplify the process. Now I extended the thing so you can simply change a certain part material to be, for example, recyclable material. So it doesn't have to be, for example, a plastic. You can change it with a wood if possible. Sorry, not wood, with the aluminum, for example, to replace the thing. And then you're going to have discussion about the cost and the machining processes. You just give you a hint that both the aluminum and the plastic assembly can be done by the injection molding or the die casting. So it's something like injection molding. Also, you need to, or you can talk about the reverse engineering, where you can have a select a product, like for example, spare part or tool, and write down an analysis for the reverse manufacturing process of the product, starting from scratch. So in this case, no engineering drawings or raw sheet again to be available. You can simply start having a part, and you think, okay, we're either going to do the measurement for it using the CMM, having all the dimension, creating the CAD model, fix it, and machine it, do the CAD/CAM operation and machining. Or you can simply do 3D scanning for the part, have the CAD model, process the CAD model, and then you can do the CAD/CAD operation for it, 3D printed or machine it. So these are some of the suggestions we can have for the second operation. And I gave you some suggestions for the first operation. We have the, for example, the laptop, which usually again to have something about 16 screw to be built in. Try to replace that by having the what they call it, this living gauge, or this is not this living gauge, what they call it, this, I forgot the name of the thing. Anyway, so try to avoid this one by using some fixture which can hold the laptop rigid and reduce the number of the screws. This, of course, going to reduce the assembly process time, and thus we're going to save some money. Right? I told you about the operation that in the old days, most of the radios or the recorders have a different size of the screws, one long, one short, and thus the timing find out the place of these screws was longer than what we have today. Now most of the laptop have the standardized size of the screw. They all have the same length and the same size. So this was an idea. Also, you can discuss it in the design for the assembly process for the parts. Okay, any questions? Okay, I got a message here. Okay.
No, all good, Ahmed. Thank you.
You find the selected. You find it. You find anything, Leo. Just think about it. Look around. Search for some example online. Take off your car apart and find something and discuss it. Okay. So I need to go now. And we are going to meet later anyway. Okay. So I'm going to check your progress by Friday. Is that good? I'm going to meet you by Friday, and we're going to have discussion about your progress.
Sir, one question before you leave.
Yep.
For the first part A.
Yep.
How many operations we need to do? Only one, or because I'm confused now when you introduce the puzzle things and stuff.
Puzzle is not easy, by the way.
Yeah, that's why I'm confused. So how many operations you're looking for?
For example, you can assemble the T puzzle, then weld it. This will be 2. That will be a quite complicated work, right?
Which one? Can you repeat that?
You can assemble the parts, the T puzzle parts, and then weld them. Okay, so this will be 2 robotics arms, 2 different operations.
And that's all what you need.
That's all what I need.
And if you decide to not shoot the puzzle, we can do any operation.
Of course, of course.
So the puzzle is not mandatory.
No. I just give you a suggestions.
All right.
Okay.
Okay. Thank you.
Okay. Have a good evening and see you later. Bye.
Thanks, Ahmed.